So we're going to be going over the past two homework assignments that we've had this week, just to make sure that we're kind of uh, knowing all this here and that we don't have any more questions or concerns. If we get through this and something is still unsure, you can always send me an email and we can either talk about it by email or Zoom if that's going to be more helpful to you. That way we can get you straightened up. This is actually going to be the second time I'm doing this video because I just did it, but then I realized that I forgot to turn on my recording. So I'm kind of ticked at myself right now, and I'm going a little bit insane. So if I just say some weird stuff throughout this video, you'll have to forgive me that. It's late at night, and again, I'm kind of ticked at myself as it is. So let's go ahead and start this here on that happy note. So we want to find the area of these shapes here. So we have a trapezoid here that we want to find the area of. So the area of this trapezoid, we know, is base 1 plus base 2 times height over 2. Um, Now, the question is, what are these numbers here? Well, base 1, 10. It's pretty easy right there. Base 2 is going to be this entire length here, which is 16 plus 6, which is going to give me 22. 16 plus 6 is 22. Yeah. Just so I don't have any angry students saying, haha, you did that wrong. I'm going to say, haha, no, I didn't. Then I need my height, all divided by 2. I don't have my height. My height's a mystery. My height's x. I don't know what it is. It's not my x, but it is an x. So I'm going to use my right triangle friend here, because it is a right triangle, to find what x is. And I notice that 10 is my hypotenuse. So I'm going to set this up as x squared plus 6 squared is equal to 10 squared. And so I'm going to get x squared plus 36 is equal to 100. And I'm going to subtract 36, and I get x squared is equal to 64. Then I'm going to square root both numbers, and I'm going to get x is equal to 8. Just solving a Pythagorean problem, square, subtract, root, and we do get that because I know that for sure. I'm not checking my work here so I don't get any students yelling at me that I did it wrong. What you're seeing now is not happening. 8, okay, yeah. So we get x is equal to 8. So that's not the end of my answer, because that's going to go back up here in this formula here and say that it's 8, because that's the height of my trapezoid. Then I'm going to do all this jazz here. So 10 plus 22 times 8 divided by 2, and we get 128. 128 yards squared, which is the exact same thing I got last time when I did this just a few minutes ago. Well, actually 40 minutes ago, because that's how long the video took, that I'm doing again. So 128 yards squared for this area. This one is going to be fun to do again, because this is quite a bit of a lengthy problem, one of the harder ones on there, and I'm going to do it for the second time in a row. So let's put on our happy faces here, because I sure don't have one. Let's go ahead and figure out the area of this kite here. So the area of the kite is diagonal 1 times diagonal 2 times 1/2. So I need to figure out what the diagonals are, which are these dotted lines here. These are the diagonals of the kite. So we have diagonal 1 up and down, diagonal 2 across. It doesn't matter which one you call 1 or 2. I'm just going to call it 1, 2. Now, I know a little bit about diagonal 2. But I don't know anything about diagonal 1, and I don't know what this part is about the other diagonal. So I basically need to find this line here first, just because I don't know anything about it. So let's go ahead and start with that. Plus, my right triangle is already down here, so I can use this right triangle as a starting point. Look over here, we see a 39, so we're going to figure out what this, we'll say x here. We're going to figure out what x is. So x squared plus 15 squared is equal to 39 squared. That's what, again, this right triangle right here is the one I'm dealing with, the one in the lower left-hand corner. So we get x squared plus 225 is equal to some big number here, which is 1521. Then I'm going to subtract 225, and I get x squared is equal to 1521 minus 225, and I get 1296, and then I root, and I root, and I get square root of 1296, which gives me 36. So this x is 36. I am recording this time. So, got scared there. Now, if this line right here is 36, That means that this top triangle, well, it's the same triangle. It has 15, and then because these sides are marked congruent, this is going to be a 39 here as well. So this right triangle is going to be the same as this bottom right triangle. So this is also going to be a 36. So I know this diagonal right here, this is going to be 36 plus 36, which is 82. No, which is 72, because I'm smart. Yes, 72. So that's going to be this diagonal right here. Now, I'm almost home free. I think I still need to find, we'll put y here. I still need to find this line right here, because I need this entire length here. Well, luckily, I have yet another right triangle to help me out. And 80 here seems to be the hypotenuse, so let's go ahead and work this one over here. So y squared plus 36 squared is equal to 80 squared. So y squared is equal to 120, or sorry, 12, I put equal to, didn't I? I'm losing it. So plus 1296 is equal to 6400. Subtract 1296, subtract 1296, and I get y squared is equal to some big number I got last time I did this. 1296, 51, 5104, and then I root, and I root, and I get y is equal to 5104, and I get 71.4. And then to end it, I don't want just the 71.4, I want the entire diagonal, so it's going to be 15 plus 71.4, which will give me 86.4. And then lastly, I'm going to plug both these into my formula. So diagonal 1 will cost 72, diagonal 2 is 86.4, and diagonal, no, sorry, times a half. And then we do all this together, 72 times 86.4 times 0.5, and I get 3110.4. And I know that is correct because that's what I got last time. So, there. Um, Again, you had to make sure you use the right triangles to get each piece of the diagonal, then add them back together, and then use the formula. So when you have kites, just be aware that you have 4 possible right triangles you can work with, and luckily they're both going to be the same when they're next to each other. So like this and this are the same triangle, this and this are the same triangle. So even though there's 4, there's really only 2 when you think about it. Here we have a circle with a right triangle in it. So again, we're going to use our friend the right triangle. Remember, for a circle, the formula is pi r squared. So I need the radius, not the diameter. In this case here, I don't have either. But I do know that this entire line here, because it goes through the center, that is my diameter. We'll call that x. That's my diameter line. So if I get this line and I cut in half, then I can get the radius. So how do I get this line here? Well, I have my good friend, the right triangle, to help me out. He's a nice friend to have around because he helps you figure out little pieces of information. So across here, we have x is going to act as my hypotenuse or hypotenuse. And so it's going to be 40 squared plus 9 squared equals x squared. 40 squared, that's going to be 1600. 9 squared is going to be 81. X squared. We add these together, we get 1681 equals x squared. We're going to root, and we get something that I don't remember. 1681, 81, 41. 41 equals x. Now we're not going to rush in and plug 41 into r because we're going to be a good student, and we're going to say, well, 41, that's the entire diameter. What am I ever going to do to get the radius? Well, I'm going to take this 41 and I'm going to cut it in half. Divide by 2, right down the middle. That's going to give me 20.5. I don't need a calculator for that. I'm just going to use it to prove that I'm right. So, yeah, 20.5. So this is my r. So now I'm going to do pi times 20.5 squared, and that, my but my precious students, is going to give me 1320.3. So 1320.25, just because I want to be more exact, squared. So, um, yeah, I'm not hallucinating yet. So that is going to be the area of the circle. We had to use the right triangle to get my diameter, have to use the diameter to get the radius, and then use the radius to finally get the area. Down here we have a sector problem because we're dealing with the slice of the circle. To find the area of a sector, it's this little setup here. Pi r squared is equal to degrees over 360. So again, area of slice, area of circle. Degree of slice, degree of circle. So slice, circle, area, area, degree, degree. That's how you can kind of remember the formula there. Now, I have most of this information, because again, I have like 9 yards there. So area of the sector, which is x, I don't know it, is pi times 9 squared is equal to 360 on bottom. Now, some of you might have put a 60 on top because degrees. 60 degrees. Degrees. So you put a 60 there because that's the degrees. However, you need the degrees of the sector. So it's not going to be 60 because 60 is the degrees of this empty spot here. I want the degrees of this sector right here. So I want this angle. I don't want the 60, I want the angle behind it, which luckily, because a full circle is 360, this is going to be 360 minus 60, which will give me 300. So I'm going to put a 300 here, not a 60. So when you have a sector problem, always make sure that you are doing the correct sector, not the incorrect sector. Because if you do the incorrect sector, you get the incorrect answer, as is no surprise to anybody. So just double check your angle, make sure it's right before you do the problem. Just like you should double check your recording before you make a 40-minute long video so that you don't go insane. So here we do pi times 9 squared, which is 81, which is, yes, I am recording, which is 254.5. So this is 254. We'll do 45 just to be a little bit more exact, because why the heck not at this point? So you cross multiply, we get 360x is equal to 254.45 times 300 gives you, wait a minute, that doesn't seem right. Did I do, no, that's right, yeah. I'm not going crazy, right? Yeah, okay, we're good. Wait. No, 47. There we go. Because the 9 rounds the 6 up to a 7, not down to a 5. What am I thinking? I know what I'm thinking. Actually, I don't know what I'm thinking because I'm going insane. So, 4, 7. There we go. That's going to make it look a little bit like I remember. There we go. 76341, which still is a little bit different, but we'll go with it. 76341. And then we divide by 360. So divide by 360, and we get 212.06. Again, if you got a slightly different answer than me, that means you probably just rounded differently, which is no big deal. So that is the area of that shaded sector there. And that is the first homework assignment. Again, sectors and composite shapes. Sectors and circles. So the second homework assignment, oh wait, no, sorry, we forgot this one. Again, I'm going crazy. So the last problem here, we have a pie that's cut into 18, or has an 18-inch diameter and cut into 10 equal slices because it has 10 friends that are going to share them. How much of the area did each friend get? So an 18-inch diameter. So in order to find the area formula, I'm going to need to take this diameter and cut it in half because I want the radius for the area formula. So it's going to be 9. So 9 is going to be the number I'm going to use here. Now I kind of drew a picture here. It's roughly 10 equal slices. I know they're not all equal, but hey, give me a break here. So if we imagine that this is 10 equal slices, each of these slices make up a sector of the circle, right? It's like this is a sector, that's a sector, that's a sector. All the slices are sectors. So I could use the sector formula pi r squared is equal to degrees over 360. And I do have most of the information. So pi times 9 squared is equal to, I just don't have the degrees. So your question might be, well, how do I get how much of a degree each sector is worth? Well, again, go back to the original thing about circles, is that the entire thing is 360, right? So 360 degrees split among 10 friends. So that'd be 36 degrees each slice. So 36, 36, 36, all the way around. So that way all the 36s would add up back to 360 for our full circle. Excuse me. So again, take the degrees, divide it by 10, get 36, put 36 right there, and then you can cross multiply. Now, an easier way of doing this actually, you can put an X there for A if you really want to. An easier way of doing this would be to think, okay, what's the area of the full circle? What's pi r squared? And if there's 10 friends and they each get an equal slice, well, that means they each get 1/10 of the area of the circle. So I just divide it by 10, or times it by 1/10 if you want to. So instead of going through the sector bit, just think about it as take the area, split it into 10 equal slices, and that's how much area each friend gets. So if we do pi times 9 squared, so pi times 81, which we did before, divided by 10, we get 25.45 for 5 inches squared. And that is the area of pi that each friend gets. So there's two ways of approaching this problem. Either way should get you roughly the same answer. If you got like 254.6 or 254.5, not that big a deal. It's probably just a rounding thing you're doing, especially if you use the 3.14 key rather than the pi key. So then that one, unless I'm going crazy, which is very likely at this point, yes, that one marked the end of the first problem. This is the first homework. This is the start of the second homework, which is on composite shapes and polygons. So to find the area of a regular polygon, and we are going to assume that this is a regular polygon because we couldn't do it otherwise. Remember, regular means that all the sides are equal, so all the sides are 10, essentially. And all the angles are equal, but that has no bearing on this problem. The way you get an area for those is it's 1/2 the apothem times the length of the side times the number of sides. Or again, you can call that this is the perimeter if you want to. So 1/2, well, my apothem's 8, and then I have a side length of 10, and I have 6 of them because it is a hexagon. 1, 2, 3, 4, 5, 6. So we just simply plug them into the calculator. Times 8 times 10 times 6. And that's going to be 240 meters squared. And again, this is basically comes from the fact that we're splitting this. This basically comes from the fact that we're splitting this up into a bunch of triangles, and each triangle has a base of 10 and a height of 8. So that's where this comes from. And then we simply times it by the number of triangles there are, which is 6 essentially, one for each side. So that's that problem. Again, very simple, straightforward one to start with. This one is a composite shape. So this one we have to kind of split up ourselves and add them back together because we want the area of the entire shape. Now, how you split it up is kind of up to you. What I would do is I would cut it right here. And what I get when I do that is you can think about it one of two ways. You can think about it as a triangle, square, or rectangle and parallelogram. Or what I would do is I would think about it as, instead of using 3 shapes, just use 2. A trapezoid and a parallelogram. That way I only have 2 shapes rather than 3 different ones. So let's find the area of this bottom trapezoid. For some of us, the second time around. That's going to be base 1 plus base 2 times height over 2. And you can ignore the pink elephant. So base 1 and base 2. What are our bases? Bases are what? Well, my base down here, 1 or 2, doesn't matter, is going to be 15 plus 3, which is going to be 18, unless the laws of math have changed, which I don't think they have, but again, I don't really know much at this point. 18, so it's going to be base 1, plus base 2. Well, base 2 is this line up here, and they don't tell me how big this line is here, or do they? Because if I go from here to here, that's the same thing as going from here to here. So they do kind of tell me, just in kind of a roundabout, sneaky Mr. Paul sort of way. So this is 15 centimeters across, which means that this is also going to be 15 centimeters across. So my base 2 is 15 centimeters. And my height they give me here is 7. No right triangle this time, thankfully. We get 7. So we're going to plug this all in here. 18 plus a 15 times a 7 divided by 2 gives me 115.5 centimeters squared as my area. Now I'm not done yet because it's the area of the bottom piece. I need the area of the parallelogram up here. So to get the area of the parallelogram, that's just base times height. A basic area. Ha ha ha, pun. So base times height. Well, I know the base is 15. That's that bottom line here. But I don't know exactly what the height is. That is a mystery to me. But I do know that the entire height is 16. So if the entire height is 16, and this down here is 7, that means if I go from, again, top to bottom, that's 16. From here to here, that's 7. Here to here, that's 7. So this would be 16 minus 7, basically whatever's left, which is 9. Which is 9. So we times by 9, and we get 15 times 9, and we do 135. And then now we're not going to end my problem here. We have to do one more step, which is add these two things together, because this is a composite area and requires us to add these two things together, and we add them together, and we get a total of 250.5 centimeters squared. Yes. So that's our total area for this composite shape thingamajigger. Again, you could split up into a triangle, a rectangle, and a parallelogram and do all three areas and then add them together, and you would arrive at the exact same answer or pretty close to it at least. So any questions on that one? He says, well, nobody can actually respond because this is a pre-recorded video. So let's go ahead and do the next one. This is another composite shape, although this one's a little bit more complicated because it has a half circle in it. Once again, I would cut it kind of somewhere like this. And you can say it's a triangle, rectangle, and half circle. I would say that it's a trapezoid and half circle. That way you only have two shapes to deal with rather than three. So let's go ahead and try to figure out the area of this trapezoid. So for a trapezoid, I have area is base 1 plus base 2, once again, times height, all over 2. So how do I get this area here? Well, let's see what I know about it first. Base 1, check, 24. Plus base 2, not check, x, times height, check, 12. Divided by 2, check, it's a constant. So I need to figure out what this top base is here, and I don't know what that top base is. Let's figure out where it goes. It goes from here to here. It'd be really nice if we had something going from here to here, but we don't. We only have something going from the entire length. So I need to figure out what this little slice is here. Then I can just copy it up on this one. Well, if I knew what this slice was, if I knew what x was, then I can simply do 24 minus x and get how big this slice is. But I don't know what x is, so I should just throw up my hands and run away, right? No, because this is a right triangle, because heights are always at right angles. So 13.5 is my hypotenuse. I can figure out what x is. So 13.5 squared is equal to 12 squared plus x squared, because again, that's a little right triangle here. So 12 squared plus x squared. This is 144 plus x squared is equal to, this is going to be bigger than 169. That's about as much as I know about that, which I think I said the exact same thing last time, is 182.25, which is 182.25. Yes, not going crazy yet. So we subtract 144, we get, drum roll, oh my gosh, so exciting. What is it? Hurry up, oh my gosh. That's 38.25. 38.25 is equal to x squared. And then we see the square root. Can't talk now, losing vocal functions. And we square root that number there, and we get 6.18. 6.18. after 8's a 4, so yeah, 6.18 equals x. So this right here is 6.18, and I know that because I did most of it in the calculator, so you can't email me saying I did this run wrong. So if that's 6.18, that means this line right here is going to be 24 minus 6.18, which is going to be something that I'm going to check here. So once again, I don't get any angry emails from students saying, haha, you did this wrong. I'm going to say, haha, no, I didn't. And I get 17.82. And then I just lost my train of thought. Oh my gosh. Okay, there it is. So if this is 17.82, that means this line right here is also 17.82. So now I have my base 1, or base 2, whatever you want to call it. I have my top base. So now I can go here and do 17.82. I don't need to cut in half yet because I'm using it for the trapezoid. So if you're saying I should cut it in half, when I get to the semicircle, I'll do that. But right now, I want the full length for my trapezoid. So now I'm going to do 24 plus 17.82, which is 41.82. So 41.82 times 12 over 2. This is how a pro shows their work. Watch and learn. Times 12 gives me 501.84 divided by 2. And that gives us a 250.92. Look at that, all nice and work shown. And we not finished the problem yet because that gives me the bottom trapezoid. So this gives me the bottom trapezoid. I still need the semicircle to add to it, and I used up all my area, no pun intended. So we're going to do some computer magic here. We're going to highlight all this. We're going to group it up. We're going to say the magic words and voodoo it down. We're going to move it off to the side. There we go. Make it a little bit bigger, and then we'll leave it there for you to admire. Little math Picasso there. So now we're going to do the area of the semicircle on top. Now, luckily for us, the area of a semicircle looks kind of weird and scary, but it's actually just the area of a circle cut in half. So that's all we do. Area of the circle cut in half. Nothing more, nothing less. Blah, blah, blah. So I still need the radius though. This right here, that's a nasty diameter. So I'm going to take my 17.82 and I'm going to cut it in half because I want the diameter to get my area because that's what the area calls for. Wait, no, sorry. I want the radius to get my area. Again, losing vocal functions. So my radius is 8.91. That is my r. That is what I'm going to use to get my area. So I'm going to do pi times 8.91 squared, then divide it by 2. So pi times 8.91 times 8.91, which is the same as squaring. This is the same thing as squaring. It might look different on you, but it's the same thing as squaring. Don't yell at me. And we get that divided by 2. I said stop yelling at me. And that gives me 124.70. So 124.70 yards squared. And then I'm going to bring these two happy couples together and get 250.92 plus 124.70 because I want to put them together, not split them apart, because this is a adding composite figure here. I want to add them together. So 250.92 plus 124.70. And our happy days are going to be 375.62. I messed it up. Oh my gosh. So 375.62 yards squared. And that is the composite area of that shape there. So another long-ish type of problem. But again, split it into shapes you know how to do. Do each shape individually, trapezoid, semicircle, and then add them together at the end. Unless you want to subtract them, which would be a case where you have something like this. If you had like a shape here, and then you had like a triangle in the middle, and it said find the area of the shaded region. This, again, beautiful Picasso picture, I know, but this would be a case where you would find the area of the big polygon, find the area of the inner triangle, and then subtract them because you want to take the triangle out of the big shape, not put them together. Here, you're putting together these shapes here to get the full area. So then the last one for a second time in a row is triangles that are similar. So we have similar polygons, we want to find the area of the larger one. Now, if we want to find the area of this one over here, we need the area of this one over here because we can't do anything without a comparison. So let's go ahead and find the area of this triangle here. So base times height divided by 2, which I can do in my head because I'm smart, gives me 7.5 inches squared. And yes, so gives you 7.5 inches squared. So now, in order to do these similarity problems, if you hear the word similar, again, losing vocal function. If you hear the word similar, what you want to do is you want to make a comparison, a scale factor, a fraction, something to give you a link between the two shapes. I need a bridge, a link between these two. We're going to build bridges. So, using math, yes. In order to build the bridge, in order to get the link, in order to put them together, you need to take a piece of one shape and match it with its corresponding piece in the other shape. So we have a few options. Namely, we have 3 and 12, or we have 5 and 12. And the question is, which one is correct? Well, in order to match up, they need to be corresponding. And corresponding means they're measuring the same type of thing in each shape. So my best advice here, and the correct answer, would be to match up 3 with 12 because they're both heights of the triangles. They're both measuring the same thing. So 3 and 12 are going to go together as corresponding pieces. They're going to be the bridge to the triangles. They're going to be the bridge that links the triangles and the bridge that builds to our answer. Look, I can be poetic as well. So we're going to use this answer bridge here, the scale factor, this link, and we're going to set it equal to the areas. Now, I know the area here is 7.5. I don't know the area here. So this area is unknown. It's an enigma. It's in the ether. It is concealed to me. I do not like that. So we're going to find the area of this shape here. So we're going to do 7.5 because we're going to be consistent. We did small triangle, big triangle. Here we're going to do small triangle, big triangle as well because this cares about consistency. So on the bottom here, I would normally put X because I don't know the area, but because I'm going crazy, I'm going to put a smiley face here. And we're going to use smiley face as my variable because I can. And now, before I cross multiply like some of your eager beavers might be doing here, and some of you are screaming at me that I'm not doing something, and I know I'm not doing something, I'm going to show you what to do next here. You have to square this fraction. Why are we squaring this fraction? Well, because area is in square units. Inches squared. It's in square units. So because it is in square units, and 3 and 12 are not in square units, 12 inches, not squared, 3 inches, not squared, I have to square this fraction. That way the units all kind of agree with each other. That way I have square inches compared to square inches. So I'm going to square these numbers here. 9 over 144 is equal to 7.5 over smiley face. Look how happy he is. He must have done his video right the first time. So then I can go ahead and cross multiply. So always remember to square your non-area fraction first. That way everything is in square units before you start your cross multiplying. So 9 inches squared now, and 7.5 inches squared to 144 inches squared. So again, everything's been squared in this fraction, so we're all good to go. Everybody's in agreement. Everybody's shaking hands. We're building this bridge here, baby. So we get 9 times smiley face, which is 9 smiley face. Happy. And then equal to 7.5 times 144, and we get 1080. 1080, I was going to make a rhyme there, but I'm at a loss for words again. So 1080, rhyme, rhyme, rhyme. We're going to divide by 9, divide by 9. So divide by 9. No, that's just a 9, Eric. Mr. Paulus, I mean. We're going to take 1080 and divide it by 9, and we get 120. So we're going to do 120 equals smiley face, and smiley face equals area. So we're going to turn this frown upside down here, and we're going to say my smiley face is equal to 120 inches squared. And this is my final answer. So whenever you have a problem that talks about similar shapes, if you're talking about similar shapes, you need this little build a bridge fraction here. You need the scale factor to link these two shapes together. Otherwise, you can't do the problem. And if you have an area in a similar problem, you have to make sure you square one of the fractions, namely the fraction that doesn't have the areas already in it. That way, everything has the same units and you're all consistent. In fact, if you do this here, 3 inches, 12 inches is equal to 7.5 uh, is equal to 7.5 inches squared over smiley face, then you can see inches, inches, square inches. That's your red flag that's saying, okay, before I multiply, I need to square first. That way this would be 9 inches squared and 144 inches squared, and then they would agree with this, and then I can cross multiply. So if you want to put your labels in there to make sure that you're getting a good consistency, you can do that too. Um, so if you still have questions on this stuff, feel free to shoot me an email. If I can help you out with email, great. If I can't and you need some sort of live or one-on-one or maybe one-on-two or whatever help, if I need to help multiple people at a time, then we can maybe try a Zoom or something like that. I'm okay with that. You just have to let me know and we can make it happen. Again, I hopefully can do this every Friday. Hopefully I remember to do it right the first time, and then I won't be going crazy. So that's it for this video. Hope it helped you out there. Why am I doing that? Uh, no, there we go. So hopefully helped you out there, and have a good night or day or whatever it is right now.